Hello students, welcome to my channel Explore Physics, Let's Explore. In this channel I'll be explaining you the concepts of 10th, 11th and 12th standard physics. I've already completed 2 chapters for class 10th science, and the chapters are light, reflection and refraction, and the human eye and the colorful world. So these chapters I've already explained you. You can refer the previous videos for that or my channel. And third also we had started. We are about to complete the third chapter also, that is electricity. So today I'm going to explain you or solve rather the numerical problems which are there in chapter electricity, which are based on electric power. As you are familiar, this side numerical problems will be displayed for you, and here to this side of the board I'm going to solve the numerical problems. So without further delay, let's start the class. For power there are 3-4 formulas which are supposed to learn, and I'm going to first write these formula for a quick recap. So one is P is equal to VI, where V is the electric potential difference and I is the current flowing in the conductor. The second formula is P is equal to V square by R, where R is the resistance, V is the electric potential difference across the ends of the conductor. And third is P is equal to I square R. So this is the third formula for power, which is equal to I square R. In one of the numerical, I'll be using the formula P is equal to W by T, rate of doing the work, or energy consumed by T. So these 4 formulae we are going to use in the numerical problems. So I've told you before also, when you just solve the numerical problems or write your notes, keep one page, the first page, for writing all the formulae for different chapters. So whenever you're going to open the book, you're going to have a quick recap of all these formulae, which is easy for you or handy for you when you solve the numerical problems. So we'll start with the very first numerical problem and see what does it say. So please remember these formula which we'll be using. And here we go for the first numerical. The very first numerical is: several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many lamps can be connected in parallel with each other across the 2 wires of 220 volt line if the maximum allowable current is 5A? So we'll write first what all is given to us. So several electric bulbs designed to be used on a 220 volt electric supply line. So V is given to you as 220 volt. Electric line are rated 10 watt. So each of the bulb is rated as 10 watt, right? Each of the bulb is 10 watt. How many lamps can be connected so that we have the allowable current as 5 ampere? So we have to find the number of resistors through which 5 ampere current can flow. So what we are going to do first, we know that P is equal to V square R. So what we are going to find? We are going to find the resistance for each of the lamp or the bulb here. We have the voltage, we have the power. So with this formula P is equal to V square by R, I can find R is equal to V square by P. So R is equal to V square by P is equal to, therefore R is equal to V square is square of 220 divided by P is 10. 220, 22, and then you have that 48400 is the square of 220 and this is 10. So we have 4840 ohm as the resistance for each of the bulb. So each of the bulb has the resistance as 4840 ohms, where the power of each bulb is 10 watt. Okay, now let's say that R, if I'm going to put it as R1 here, easier for me, because now say R is the total or equivalent resistance. Total, net resistance, equivalent resistance, whatever you say. R is say the total resistance of the entire circuit. So we know that V is equal to IR. From here, R is equal to V upon V by I. V is given to us as 220. I is given as 5 ampere. So I'll have, therefore, R is equal to the total resistance of the entire circuit is 5 4s are 20 and 5 4, so 44 ohm. So I know now the resistance of each of the bulb, plus I know the resistance of the total system. So I can easily find total number of resistances which are to be connected in parallel for the maximum allowable current as 5 amperes, right? So I know this 4840 and I know this 44 ohm. So what I am going to do now, this side you can see the numerical problem. So what I can do, say the number of resistances are X. Say we have X number of resistances. We have to find the number of resistance now. Say it's X. Now we know that 1 upon R, the total resistance when they are connected in parallel, will be equal to 1 upon R1 plus 1 upon R2 plus till X times, because X numbers are there. So till X times we have 1 upon R1 plus R2 and all. So we know that the total resistance is, therefore total resistance we found 1 upon 44 is equal to, all are same resistances. So 1 upon R1 was 4840 into X times. So it will be equal to X upon 4840. So we have the relation here that 1 upon R, the total resistance, 1 upon R was the total resistance of the circuit, that is 44 ohm, is equal to individual 1 upon individual resistance. So 1 upon 4840 into X, because we have assumed the number of resistance are X. So from here, therefore, X will be, we know, I'm writing it again, 1 upon 44 is equal to X upon 4840. That implies X is equal to 4840 by 44 is equal to, X is equal to 44 ones are 44, then 44 1 again, 110. So the number of resistances which are to be connected in parallel so that the maximum allowable current is 5 ampere is 110 bulbs or 110 resistances bulbs. So each one will have R1 4840 ohms the resistance. So this is the solution for question number 1. We are going to start with question number 2. I told you before also, children, please keep on practicing the numerical. Learn all the formulae to make yourself perfect in numerical, and then it becomes easy for you. The second numerical is 2 lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric main supply. What current is drawn from the line if the supply voltage is 220 volts? So what all is given to us? 2 lamps, one rated 100 watts. P1 is equal to 100 watt at 220 volts. V is given to you as 220 volts. For this, V is given to you as 220 volts. And the other 60 watt. So P2 is given to you as 60 watt and parallel to the electric supply, V is equal to 220 volts only, right? P1 and P2 are given to us. You have to find the current. They are connected in parallel. Okay, what current is drawn from the line if the supply voltage is 220 volts? So first we are going to find I for both the cases. So we are going to name it as I1 and I2, and addition of I1 and I2 will give you the total current flowing in the circuit. So we know that P is equal to VI. So P1 is equal to VI1. Therefore, I1 is equal to P1 by V. P1 is 100, V is 220. So it will be, P is 100, yeah. So it will be 5 by 11 ampere. So I1 we found it to be 5 by 11 ampere. Similarly, I2 will be equal to P2 by V. P2 is 60, V is 220, that is equal to 3 by 11 amperes. So we found I1, the current flowing through 100 watt power, or the 100 watt bulb, whatever they are given, the bulb or what bulb, and I2, the current flowing in the 60 watt bulb, is 3 by 11. So therefore I is equal to I1 plus I2 is equal to 5 by 11 plus 3 by 11 is equal to 5 plus 3, 8 by 11 ampere, or I is equal to 8 by 11, so 11, 7, 0.7, 3, so 2 and 7, 7.27 ampere. So we found R to be 0.727 ampere. That is the current flow, the total current flowing in the circuit. Solution for second numerical problem. Please like, subscribe and share my channel if you like the content. People are coming, viewing it but not subscribing it. So please subscribe the channel. So I hope it's clear to you. Now we'll come to the third numerical. So the third numerical says, which uses more energy? A 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes. So P1, if I am referring it P1 as the TV set, so P1 is equal to 250 watt and time is given to you as 1 hour. P2, the other thing is given to us, P2 is given to us 1200 watt toaster. So 1200 watt and time is given to us, I think, yeah, 10 minutes. Time is given to you as 10 minutes. Which uses more energy? So what we are going to use, the formula is P is equal to E by T, the rate of consuming the energy is called the electric power. From here, E is equal to P into T. Therefore, E is equal to P is, if I'm referring it as E1, so E1 is equal to, P1 was 250 into T was 1 hour. So is equal to 250 watt hour. Okay, 250 watt hour, and E2 similarly will be equal to P2 is equal to 1200 into T is 10 minutes. I'm changing it into hour by dividing it by 60. 10 minutes, so I'm going to change it into hour, so it is equal to 10 by 60. I'm going to divide it by 60 to change it into hours, because 60 minutes make 1 hour. So it will be 200, 6 2s are 12, so 200 watt hour. So which uses more energy? Naturally E1. So E1 uses more energy than E2. So TV set of 250 watt will use more energy than the toaster of 1200 watt. Now see here, the purpose of the question on the they are only answering, you only have to answer that which uses more energy. So you don't have to change it into seconds, don't have to, instead of 1 hour you just put it 3600, multiply with that. Don't make the thing clumsy. You only have to give the answer that which uses more energy. So just take it in hours only, no need of changing it. If you want to change it, you can put it here, instead of 1 hour you can just put it 3600 seconds. Here instead of 10 minutes you just 10 into 60, so 600 seconds. So that's how you're going to solve it. So this is the third question. Keep on practicing, as I always tell you, keep on practicing the numerical problem. These are the basic numerical problems where we have used all the formulae which are there in for power. So please keep on practicing. So you have the power based numerical problems. So most of the questions will be based on these formula or this type only. So now the fourth question is, a refrigerator having a power rating of 350 watt operates for 10 hours a day. Calculate the cost of electric energy to operate it for a month of 30 days. The rate of electric energy is rupees 2.40 per kilowatt hour. In the previous class, I discussed it with you that 1 kilowatt hour is considered to be 1 unit of electrical energy, and kilowatt hour is the unit of electrical energy. So these many kilowatt hour, n number of kilowatt hour will be considered as n unit. So you have to find how many kilowatt hour is consumed. That is one thing. Second, this is a billing question. These type of questions definitely will be asked. So maybe instead of one, there will be 2-3 things. So you just individually find the power consumed or electrical energy consumed and add it up. That is the billing based question. So which is this. So having a power rating of 350 watt. So P is given to you as 350 watt. Operates for 10 hours a day. So T is equal to 10 hours. No need of changing it. Calculate the cost of electrical energy to operate it for a month of 30 days. So T will be equal to 10 into 30 because days are 30. So we have 300 hours. So 300 hours we have the time given, and you have to find the electrical energy and then the cost. This for 30 days. So P is equal to E by T. Therefore, E is equal to P into T, or E is equal to P is 350 into T is 300 equals to 1, 2, 3, 1, 2, 3, 4, 5. 1,05,000. Correct now? 1,05,000 watt hour. So this is the electrical energy consumed for 30 days. Now 1 kilowatt hour is equal to 1 unit. So we'll change it into kilowatt hour, or E is equal to 105 divided by 1000 kilo, K small, kilowatt hour is equal to 105 kWh. So E has come out to be 105 kilowatt hour. Now you have to bill it. So cost is given to you as 2.40. I think 2.40. Yeah, 2.40 per kWh. So we have, therefore, the cost will be equal to 105 into 2.40 rupees is equal to, this is rupees. So it's equal to, it is equal to 252 rupees. So rupees 252 is the cost for running a refrigerator 10 hours per day for 30 days. So rupees 252 is the total cost, or if the refrigerator is used for 10 hours and for 30 days. So this is the solution for fourth question. I hope it's clear to you. Keep on practicing. So that's all for the day. Stay safe, stay healthy, and a very big thank you to you. Do subscribe, like, and share my channel. Thank you. Bye-bye.